Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Sanaida.
And in studio with us we have Jacob. And Jacob, if somebody needed to contact us, what would they need to do?
For math homework, help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@current.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Jacob, where do you go to school and what grade are you in?
I go to William Penn Elementary and I'm in 5th grade.
All right, so William Penn, what are the mascot? What's the mascot of?
A panther.
A panther, so the Penn Panthers. All right. And have you been at William Penn for a long time?
Yeah, 6 years.
For 6 years. So do you go to a middle school next year or do you have 6th grade at Penn?
Middle school next year.
So you go to middle school next year. Do you know where you're going to go yet?
Not yet.
Not yet. Is there anything that you're looking forward to or you're kind of anxious about with middle school?
I'm anxious that I can't go to a middle school with my friends.
Yeah, because you're going to have some of your friends go to the same school with you, right? And then some will go to a different school probably. But then guess what? You'll be able to make new friends also, right? Because they'll be coming from different schools, right? That's not a bad deal, is it?
Mm-hmm.
How's 5th grade going so far?
It's been going really good.
Yeah. What kinds of things have you done in math so far in 5th grade?
I've done fractions, least common denominators, and yeah.
Okay, so you feel pretty good about that stuff.
Mm-hmm.
All right, because fractions, I know that you guys hit a lot in 5th grade, because guess when you're going to do fractions again?
6.
There you go. And you know when you're going to do it after that?
The rest of middle school.
Yeah, there you go, the rest of middle school. And guess when you're going to do it after that?
High school.
There you go. You're going to do. Guess when are you going to do it after that?
The rest of my life.
That's the one I was looking for, right? You're going to do it for the rest of your life, right? At some point, you're going to be dealing with fractions, decimals, and percents kind of all the time, all right? So as long as you're getting comfortable with them and learning about them right now, that's the best thing. Have you ever done anything with perimeter and area?
Mm-hmm.
A little bit?
I'm not that good at it.
Well, you know what? Let's take a look at it together right now, shall we? All right, let's take a look at today's problem of the day. This was put out on social media today, and we'll take a look at what they had, and we'll see what the problem was. So here it is, the math problem of the day. It says find perimeter. Do you know what perimeter means?
Like the area.
Okay, so we have perimeter and area. Those are two different things. So what do you think is the difference between the perimeter and the area if we have a rectangle like what was on the problem?
I think the perimeter is like the length of the lines.
Okay, so it's the distance around it, right? It's the length of all the lines, right? And the area is everything that is within those lines. Make sense? So the perimeter is around it and everything inside of it is the area. So let's take a look at the problem once again and see what a lot of people were putting down. So we see that it's 3.7 centimeters on two sides, and on the other two sides it's 2 3/10 centimeters. Now a lot of people, we have 4 different options up there. We have 8.51 centimeters, 6 centimeters, 12 centimeters, and 9.7. Just quickly, which one do you think it might be? If you had to guess quickly.
6.8.
6.8, why do you think that one?
I tried to add the perimeter.
You tried to add them up pretty quick, right? So 3.7 is about what?
3.7?
Yeah. It's about what if you had to estimate? Do you think it's closer to 3 or closer to 4?
It's closer to 4.
Okay, so if you have 2 of those, it's going to be about 8. And 2.3, is that closer to 2 or closer to 3?
It's closer to 2.
It's closer to 2. So think about this. If we had 2 of them at 4 and 2 of them at 2, what would those all add up to be?
12.
12, right? So let's take a look, and I think 12 is one of the answers, and that's actually the correct answer. But a lot of people put 8.51. Do you see any reason why somebody might put 8.51 instead?
Probably they tried to add, so they had to times the 3.7 and the 2.3.
That's exactly what they did, right? They times them. They multiplied those two, right? Because if you multiply those two numbers, you're going to get the area, and that's a little different than the perimeter, isn't it? All right, nicely done. So see, you figured it out all right there, okay? So that was today's problem of the day, and just wanted to clarify that a little bit, and Jacob kind of figured it out also, why a lot of people were putting the 8.51 because they were doing the area quickly without doing the perimeter. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. For those of you that are new to Do the Math, the show is basically a program where we help kids, any math ability, any age, help them with their homework. And all they have to do is call in. We help them with the homework if they would like to see it performed on TV or on the internet. We're more than happy to do that. We also have professional students in every day with us, right? You are a professional student, right? You're a student all the time, right? So we have students come in every day, and we see how they approach math problems also, so that students can see how other students solve math problems. But before we get you to work, are you ready for one more thing? All right, let's take a look at today's Math in the News. All right, so today's Math in the News has to do with, but you know what? I'm going to put you on the spot here, Jacob. Are you ready? And I'm going to put Zenaida on the spot also. What has been going on that is a really big story in the news?
The floods in California.
You are on it right there. The floods in California, right? All of the rain and all of the weather in California, right? Now, you said you've been going to William Penn for 6 years, so you've been in Bakersfield for a long time. Have you ever experienced this amount of rain in this short of time?
No.
No, I don't think I have either since I've been in Bakersfield in California. But a lot of rain has been going on, right? Now, if there's a lot of rain where we live, in the mountains there would be a lot of what?
Snow.
There would be a lot of snow, which is very good for California because, as you may...
It doesn't snow a lot.
Right, it doesn't snow a lot, right? And we need the snowpack to help keep everything flowing in the spring and summertime, keep the water flow going. Anyway, with snow, we get snowflakes, right? So that's today's Math in the News. We're going to take a look at different snowflakes. And I just found this story fascinating. When I was looking at this, I was thinking, all right, the weather's a big thing in the story, in the news. With that comes the snow. Have you ever seen a snowflake? Have you ever been in snow?
Yes.
Okay, so you've traveled someplace, right? Okay, do you remember where you went to go see snow?
In the mountains.
In the mountains? Was it in California or someplace else?
California.
In California, all right. Do you remember ever seeing snowflakes up close and you kind of, did you ever see something like what we're seeing on the screen right there?
No, but I didn't get to see snowflakes, but I got to see snow.
Okay, so you got to see snow. Did you taste the snow?
No.
No, you didn't taste the snow? All right, sometimes kids, they go on and they're like, I taste snow for the first time. You make snowballs?
Yeah.
All right, there you go. That's a big thing. You got to be able to make snowballs, right? So anyway, we've got some information about snowflakes right here, and we're going to be looking at the math behind them. So this, it takes 40. Imagine taking 40 photos of the same thing, highly focused images stacked on top of each other to create one photograph. Now, what do you notice about these snowflakes that is maybe the same or different?
I noticed that they're all different shapes, and sometimes they have like, one thing I noticed that they're the same is they're always like a star shape.
Okay, so they look like a star shape, right? How many of these sides are there?
There's 6.
And are there 6 on this one also?
Yes.
So that's a little something that's the same also. But the 6, they're different, aren't they? With how they're formed, okay? So they start off as prisms. You know what a prism is?
Yeah.
Okay. Well, we're going to take a look at some in a little bit anyway, right? They have 6 sides. And at some point, they change a little bit, right? Because much like hailstones, they go back and forth in the atmosphere. They go up and down based on the temperature, all right? Which is how they get different types of snowflakes. Then we can see here how they've got a bubble collapsing in the center, and with the right angle, you can see the colors inside the snowflake also. Next time you're in the mountains or you're around snow, if you can, see if you can get something dark, maybe a sweater or something, it doesn't matter what it is, something dark, and have a see if you can see some of the details in the snowflakes. And you'd be surprised how easy it is once you kind of look at them and do that. So we can see there are different types of snow crystals, and here you can see how they're formed based on the temperature also. And then we have all of the different shapes that go along with the snow crystals. Have you ever made crystals? Mm-hmm. You have. Do you remember what kind they were or when you did them?
I got a gift from my mom. It's a crystal pack where you get to make some.
Oh, good. So you were able to do that. You put them on some string probably, and then...
Yeah, and at class in 4th grade, I also made a snowflake crystal.
Oh, good. So you're pretty familiar with this stuff. You've done a lot of stuff so far. All right, let's keep going. So types of prisms. So are you familiar with any of these? Do you remember seeing any of these any place?
They're like 3D.
Right, exactly. So a prism is three-dimensional, right? And you can see that we've got some different types here. And here are some examples of when you would see them in real life, right? So a salt crystal, right? That is a prism, it's a cube, right? Ice, and then sugar. So if you ever look at sugar and salt, if you just pour some out on the table on a plate or something like that, and you get a magnifying glass maybe, and you look very closely at them, you'll see the crystals that they are and the geometric forms that they are, the prisms that they are. Pretty cool, huh? All right, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. Jacob is a 5th grade student from William Penn Elementary School. Has been there for 6 years. What do you think is the best thing about Penn Elementary?
The best thing is how everybody's really nice, and
Well, that right there is probably the most important thing, right? Because if everybody is nice, you can do a lot more things, right? You're not nervous about things, and everybody's kind of getting along and stuff, right? All right, you ready to do some work? All right, over to the board, young man. So, Jacob, have you ever done anything called order of operations?
No.
Oh, sweet. This is going to be a big day for you, all right? So Zenaida is going to work with order of operations with you. So here's the problem. So start all the way over on the left-hand side, Jacob. All right, and I'm going to read this to you. You're going to write it down. So we have 40. You know what? We're going to start with an easy one since he's never done it before. So go ahead and write 40 up on the board.
Oops.
That's okay. You start right there if you want. Oh, use the eraser part.
Oh, sorry.
There you go. I knew you had that down. All right, so 40 divided by 2 plus 8 minus 10. And Zenaida's going to go over with you some basics on how to start this problem. But before we do, what do you think you would do first?
Out of all of them, you should always do the times or the divide first.
All right, well, you and Zenaida take over and let's see what happens.
All right, so let's go ahead and start there first then. You only have division, so you can start with a division. 40 divided by 2.
20.
You can record that underneath there. Very good. And what would you do next?
You would 20 plus 8.
Okay, go ahead. And then what would you do next?
You minus it with 10.
Okay. Okay, your answer is?
18.
18. Tell me what you did here. First step, second step, and third step to recap it.
So first of all, I started dividing 40 with 2, which makes 20. Then I added the 20 with the 8, which makes 28. And then I minused it with 10, which made 18.
Awesome. And so I noticed that you said that the first step was to start with division and multiplication. And then your next steps, I see some addition and subtraction that you ended with at the end there. Does it matter if we do the addition or the subtraction first?
Yeah.
Tell me more.
Because if you added these first, then once you divide it, it would be different.
Okay.
All right, hot shot, here we go. You're going to leave that just the way it is because we're going to use the same numbers. So above that, maybe use the other marker and we'll do red.
Okay.
So above that, high up, if you can, put the 40. So way above it, right? 40 up there again. And then put the 2, and then the 8, and the 10. So now here's what I want you to do. I want you to put 40 minus 2 minus 8, and then I want you to do times 10. So now you and Zenaida talk about what you think you should do first.
What should we do first here in this problem?
I think we should do 10 times 8 first.
Okay, go ahead. All right, so what do we do next?
We should minus the 80 with the 2. Like,
Minus the 80. So you have 80 on this side, and then you have 40 minus 2 on this side.
wait.
So you want to take away 80 from...
So remember, he has a
40.
negative 80 if he's going to
Yeah.
do that also. So Jacob, do you know why that's a negative 80 instead of just 80?
If he's a 5th grader,
Yes.
he might not be working with negatives yet. Have you worked with negative numbers yet? Okay.
Well, that's why it's a big day for the young man.
Yeah. So this is 80, but because of this minus sign, this becomes a negative 80. And this is something that you will be learning in I think 6th and 7th grade. So this 80 is actually a negative 80, which I don't know if you've worked with negative numbers before, but we can label that for now. You can think of it as this number, negative 80, is, you think of the number 0, it's 80 below that number 0, so it's a really, really small number. So you would label it with like a little negative in front of it. So Jacob is doing negative numbers here. So that's a negative 80, okay, for that reason. And then you can kind of work with what you have over there, if you would like. Okay. So you have 38, which is positive, which you've worked with before, and now you're looking at this number that is minus the 80, which is a negative 80. So your answer would come from that. What do you think that could be?
I think you should add the 38 with the minus 80.
Okay. How would you do that?
I would minus the 80 with 38.
Okay. You could do that, some of that work on the side here if you would like to.
And first, we have to borrow 1 from the 8, which makes it 7, and we have to make this a 10. And then you have to minus it, which makes 2. And then you get 42.
Oh, and why do you know that's negative?
Because we still haven't, like, if we add an 80 with here, it makes it 1 again, but we only added 38.
Oh, that is so interesting. Let me see if I can draw that out in a number line here real quick for you. So this idea that this distance between, so I'm trying to figure out, so if you are at this negative 80 right here, and, or maybe I should do, let me see if you can show this in a number line. I'm trying to see if I can show it in a number line. Maybe I should let you try to demonstrate it in a number line. Because you had 38 minus 80. So let's say this is the number 38, which is a positive number. And we're going to go back 80. And so let's see if I can show you that. So maybe here is 0, right? If we go back, So here's a number 38, but we have to go back 80. So let me see if I'm trying to show you where you can land at the negative 42, because this distance right here is what we're looking at here. And maybe I can get some help from you. Do you think?
Yeah, so
I'm
what
trying
he
to-
did exactly is perfect, right? Because what he did is he found the difference between 80 and 38, and he knew it was 42. And since negative 80 is larger, he knew that the answer had to be negative 42. So by going from 38 back to 0, he moved 38. And in
that's
order to
38.
get to 80, you would go 80 minus 38 to figure out how many more he needs to go, which would be 42.
Okay.
And it's on the negative end, so he knows it's negative 42.
He did awesome.
So, yeah, I was going to say,
working with negative numbers.
he may not have thought that he was doing negative numbers in class, but he knows instinctively from whatever other math that he's had so far that he was able to do that, right? So see how easy, see, all you had to do is you reasoned through it, and that was perfect.
That was
Exactly what you
amazing.
did is exactly what I wanted to
That was
see.
awesome.
So without having to formally go through positive and negative integers, you kind of reasoned your way through that one. Pretty good?
That's
Yeah, nice
awesome.
job,
Good
dude.
job.
You know what? For a great problem right there, you've just got yourself a meal courtesy of our friends at Broken Yolk Cafe. So congratulations on that. Have you ever been to Broken Yolk Cafe? Do you like breakfast? Breakfast is good. Ooh, yeah, I'll tell you, old man, I like eating that breakfast up. What do you like to have for breakfast?
I like to have fried egg, sunny side up, and fried rice.
Ooh, there you go. Some sunny side up eggs and stuff like that. But they do that at Broken Yolk. They'll make you eggs any way you want. All right? So congratulations, and hopefully you have a nice meal when you head over there. Hey, we do have phone tutors available until 5:30 this afternoon. But right now we're going to take a look at another one of the tools of mathematics.
Hi, I'm Nancy Gordon. I'm the Director of the Health, Safety, and Wellness Department with Panama Buena Vista School District. This is another mathematical tool that some of our students may need to utilize during the day. Obviously, this is a little bit bigger than most of our students would use on our campuses. This is just here to show you kind of what we're looking at for measurements. This is called a syringe, and syringes come in so many different sizes. Again, this is novelty, so it's really, really big. You'll see some that are this size that are a little bit more to normal size, but the one I'm gonna be speaking to you about today in particular is called an insulin syringe. And insulin syringes are even smaller. Many of our students are impacted by what we term as type 1 diabetes. It's a juvenile type 1 diabetes, and it means that they rely on insulin to help them make it through the day. And so many of us, we have a pancreas that's working full-time, 100%, doing everything that it needs to. But those students that are impacted by type 1 diabetes, their pancreas has given up and it's done. So we take the syringe that they need to have their insulin and we provide that to them during the school day. We have several students that are impacted by type 1. So if you're one of those, know that you're in good company and you have nurses on campus that are so happy to help you be safe when you're here on site. So I'll give you some examples and we'll add some numbers to this information. If your friend had a lunch she brought for that day and it was 45 carbs, and her doctor has shared with her for every 15 carbs you take, you need to have 1 unit of insulin. The magic number of units of insulin that she's going to need is 3. So again, you're going to take that 45 and for every 15 carbs, it's 1 unit. So you're dividing that, you come up with 3. And then your friend would get 3 units of insulin. So then we know that she's good to go. She has her lunch, she gets her insulin shot, and off you go to enjoy the rest of your lunch. So again, this is a syringe and it's used primarily on our sites for our students that are impacted by type 1 juvenile diabetes. And every now and then we may get a few students that also need this for some other medical concerns, but diabetes is the number 1. So support your friends that may have to come up to the office for their insulin. We want to be there for them.
There we go, another one of the tools of mathematics, and once again, thanks to Nancy for helping us out with that. We do have phone tutors available most Tuesdays and Wednesdays. All you have to do is give us a call. We'll help you out. We have Jacob, a 5th grade student from Penn Elementary, in studio with us today. And today also we are fortunate once again to have a member of the Bakersfield Symphony Orchestra with us. Jeff, how are you today?
Very good.
And what is your role with the symphony?
I play clarinet, bass clarinet, any other kind of clarinet that they need.
Okay, well, how many different clarinets are there then?
Well, I have 4 with me today.
All right, excellent. What will you be doing with Jacob today?
Well, we'll start off with a little bit of work on tempo, the speed of the music, and then we'll get into more fractions with the notation. All right. So, Jacob, you told me you've done a little bit of clarinet,
Yeah.
and you're also doing violin. What I want you to do, the upcoming symphony concert, we're going to be featuring the music of Harry Potter. Keep me a beat for me, so you can clap or on your knee or whatever. Something like that.
Is this
Can you
okay?
just boom, 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 boom. There we go. Get ready? There it comes. Keep going, keep going. You're going to be keeping my time for me. Ready, go. All right, so that was one of the tunes, right? You recognize that one?
Yeah.
All right. So that was sort of a slowish tune, right? So now I want you to go about there. Now, this is a faster one, right? So keep that one going. All right, 1, 2, ready. Now we got a faster one, right? All right, so we're going to talk a little bit more about fast and slow and stuff like that. Have you ever seen a metronome before?
No.
All right. So back in the old days, you know, like in the 1800s is when these things were first invented. Have you heard of a fellow by the name of Beethoven? Oh, well, he was a composer back then, and he made use of the metronome. These days, and so back in the old days, it was like this bar that went back and forth, and it sort of ticked, right? And these days, of course, you use your phone, and you know, it has a number on there, you know, nothing terribly exciting to worry about. But you can hear that, right? And that's sort of like that slowish one we did earlier, right? And so you see down here, we've got this number 60, right? Now, do you know how many seconds there are in a minute?
60.
There are 6. Oh, that's exactly what it is. So if our clock up here worked, you would see the second hand moving, click, click, click. Unfortunately, that guy's not working, but that's moving at 60, okay? And a lot of times in music, we use Italian words, okay? So adagio is the first one I have up here. That's sort of kind of around that 60 range there. So here's, introduce this guy here. So first, not that one, this one. Here's the regular clarinet like you would have been playing, okay? And this guy here is a bass clarinet, all right? And it's basically twice as big, all right? So do you think it's gonna be higher or lower?
Lower.
Good, all right. So here's, you know, this three fingers is one of the first notes you learned. There's that. Here's those same 3 fingers. Down lower, right? Okay. So the bass clarinet gets to play low notes. So at this adagio speed, about 60, you know, so that was about there, right? So here's just a little tune that's from a symphony. that sound familiar at all?
I think it kind of.
It's actually sort of a weird version of Frere Jacques. Frere Jacques, Frere Jacques, right? But it sort of sounds like Jack is sad, right? It's a little bit different, but it's actually based off of that song. And so one of the things I was going to show is, while that's going at that speed here, if you look carefully, you can see bass clarinet, right? And you probably recognize some of these notes, right? From both your clarinet and violin playing, right? Okay, that's about in the area that you normally do, all right? Now look down here. After I play that, I have to switch to the clarinet in S. Or that's German for E flat, which is this little guy here. So here's our regular clarinet, and here's the E flat clarinet. We sort of kind of call it the piccolo of the clarinets. So here's that 3-finger note again. So it's higher up, right? So after playing that slow thing, then I have to switch to this guy and play. Okay. So anyway, we've got the E flat clarinet, and then let's see. I might come back to that. Let me do this. Here's a tune. Now, this guy here looks practically the same, right? Mm-hmm. All right. Let me take this off and hold him up there. Now, what do you notice?
It's taller.
Ah, yeah, one of them's a little bit longer. So this is the one that you usually play in band. But in orchestra, a lot of times we use this one. This is called the B flat clarinet. This is called an A clarinet. So let me play that C again, or the 3-finger note. And on this guy, it should be a little bit.
The toner is down.
Yeah, a little bit lower. All right, and bomb, a little bit down. See if you recognize. Oh, I forgot. I skipped my andante. That's all right. I'm jumping to my moderato. So andante was about 80, okay? And I'm just going roughly by 20s here. So I'll do a moderato one. So just so you can hear it, there's our 60, right? There you go. So 80, a little bit faster. We'll see if I come back to that one. So now here's 100. So the idea is with these numbers, it's how many beats in a minute. So if you were to watch the second hand go around and count up all those beats, you'd have 100 by the time it went all the way around, okay? So keep me a beat there. See if you've heard this tune before. Have you ever heard that before?
Yeah.
Oh, do you know what it is?
No, but I think I heard someone play it before.
Okay, good. Well, it's from a piece called Peter and the Wolf. And different instruments would represent different animals in the story. There's a story that goes along with it. And that's, the clarinet is the cat. And so that's the cat slinking along in the grass there. All right. And then one last one of these guys. And we'll bump it up another 20. And that's allegro. So let me get some math going here. So what's the difference here between 60 to 120?
The difference is a 60
Good, or it's twice as fast, right? So let me put this back at 60. So if you had a clock with a second hand, and you can see the seconds going by like that, if you get that going twice as fast, we'll be up at 120, right? Bup, 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 bup. Can you tap that? So for every one of these, we're doing 2, right? Going twice as fast. So keep that going. See if you've heard this one before. I'll go ahead and use this one. Have you heard that tune before?
Mm-hmm.
Yeah, usually on the 4th of July. That's the Stars and Stripes Forever. It's a march. Most marches go at that 120 speed. All right. So we've got speeds, slow and fast. Okay. Now, if everything were exactly the same length, so we've got these beats, pulses going by. If everything were the same length, we wouldn't be able to tell what anything was, right? So we need to be able to say, okay, something is slower, something is faster. Because if we take, for instance, let's go back to Harry Potter for a second. And if we make everything all the same speed, see if it sounds like the song anymore. Does it sound like the song?
No.
Not really, no. You can hear the notes in there, but it's the tune's like there's no longer a tune. All right. So that's where these guys come in. You've seen these before, right?
Yeah.
Okay, go ahead and stand up there. And over here, the way I like to do this is a pizza. Now it's a real cheap pizza. It's only got 4 pepperoni slices on it. All right, so well, I've got a whole pizza there, nice and yummy. How many pepperoni slices are in there?
4.
4 of them, okay. So we come over to here, and I know you've just seen these guys before. So just by doing the open circle like that, we call that the whole note. All right, and do you remember how many beats are in a whole note?
No.
Okay, well that's where my pepperonis come in. How many pepperoni slices do you see?
4.
4, all right. All right, so now what have I done to my pizza?
You split it in half.
Yeah, let me try a different one of these guys. There we go, split it in half. And instead of sticking it down the middle, we just sort of stick our slice off to the side like that. So there's our half note. So how many pepperonis in there?
2.
Right, so there's 2 in here, and there's 2 for that one. All right, and what have I done to my pizza?
You split it in 4.
Good. Little 4ths, right? Okay, and how many pepperoni slices are in there?
4.
Well,
I mean,
in each slice.
1.
1 in each slice. There you go. Good. All right. We don't call these guys 4ths, do we? What do we call them?
A full? Oh no, a quarter.
Quarters. Good. Quarters. All right. So these 2 words, a little interesting thing, mean exactly the same thing. All right. We just use them in different places. So for quarters, money, and music, we use quarters. Right? So if I took a dollar bill and I tore it into 4 little pieces, what would I get?
It's still a dollar bill, but you cut it in 4ths.
Well, that's true. I wouldn't have any my money left. But what do we call those things?
Quarters.
Quarters, right? So that's what you get. Splitting the dollar in 4ths is you end up with quarters, right? So we call these guys quarters. You wouldn't go up to your friend and say, "Hey, can I borrow a 4th?" No, you say, "You'll have to go borrow a quarter." All right. And in your math class, when you see that, normally you would say
1/4.
1/4. Now you could say it's 1/4, But your math teacher might look at you funny and going, well, yeah. That's just, we don't normally do it that way, right? So money and music, we use the quarters, but they mean the same thing. All right. Oh, okay. And this one here, do you know what this guys are called?
No, I forgot.
All right. Oh, I don't want to use pink. I'm going to split everything in half again. How many slices do I have?
8.
8 of them. Good. So we call these guys eighth notes. And do you know how long they are? Or how many pepperoni slices are in each one?
For 8. Right?
Well, so
Two,
here's
one,
one slice. How much of a pepperoni is in it?
half.
There's a half a pepperoni slice in there, right? So this guy is worth a half. This one is worth a half. And we hook them up together like that. But each of these is worth a half. Half, 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 half. All those guys are halves. Okay? One other thing before we leave this guy. So we've got another way we could look at that. Whole, half, quarter, right? Eighth, 1, 2, 4, 8. Do you know what the next number is going to be?
1, 2. Oh, sorry.
So if our pattern is 1,
110.
2, 4, 8,
110.
10. How do I get from 1 to 2?
Oh, you added another one.
Okay, I can add it. Do you know another way you can get from 1 to 2?
No.
How about times? 1 times
Oh,
2 is,
2,
and if you go 2 times 2,
4,
2 and 4 times 2,
8,
8 times 2 is
16.
16. So that's going to be the next note coming down here. And the way we show that, now right at the moment I've got 8th notes going. We want 16th notes. We start adding in those guys. So and then the next one would be 32. And we'd add that on, and then it'd be 64th, and it'll just keep on going like that. Okay.
Then you get into some complicated music there.
That's right.
All right, Jeff, if somebody wanted to know a little bit more about the Bakersfield Symphony and some of the shows that are coming up, where would they need to go to?
Well, the website is bsonow.org.
All right, well, fascinating with all the different clarinets. I thought, hey, there's a clarinet, but obviously there's a lot more specific types of clarinets, and I like how you went over the math with Jacob right there, and then how to talk about the terminology and then applying the fractions to it as well, and getting a little Italian in there at the same time.
There you go.
So nicely done. Thanks for coming by today.
You're
We do
welcome.
have phone tutors available until 5:30. Right now, we'll take a look at one of the latest projects with CTEC.
probably don't think that they will be using a lot of math, but the math that we use here in video production and advanced film and cinema really has to do with real world problems and solutions like budgeting. We investigate how much are their costs, and then the students learn about how much their time is worth in the real world. So if they were doing an actual video production project, a film, if they were doing a commercial, if they were doing some type of promotional video, they figure out how much their proposed budget is, and at the end, after keeping track of what their time was really worth and all of the equipment that they use, then they come up with their final budget. So that is one way we use math. Another way that we use math would be through the timing of the shows. We have to know exactly how long sound bites are and figure that into the overall total running time, or TRT, of our pieces.
Can I say two things? Two things. One is going out to places and actually recording, because that's pretty cool. And then the second thing is putting all that stuff on my resume.
To be successful in this class, it's just like being successful in life. Show up, follow the rules, and do your best. That's really the biggest part of it. And by follow the rules, we treat this as a very professional work environment, and we take very good care of our gear as well. So that's really the best way to be successful. Show up, do your work, follow the rules.
You always have to be doing something, either editing, shooting a video, in the audio booth, doing a podcast, or in the studio, just trying to make a news type video.
In this class, we make short films, commercials, PSAs, and podcasts.
The best advice I have for incoming students is don't be afraid to get outside of your comfort zone a little bit. I know it can be tough, but the friends that you will make in this class will be lifelong friends. Don't be afraid to try something new. Don't be afraid to push buttons. Learn about all the different careers that are out there, and just be confident. Your work is good, and if I can help students realize that, then that's something really important that we try to do across.
It's so amazing because we get to do things that not even some news studios get to do because of all this equipment we have.
Working with all the high-tech stuff we have, it's pretty neat to get your hands on it and understand how it all works and see how it works. It's really fun and interesting.
And there we go. Once again, a big thanks to all of the staff and students at CTEC. And that video right there was 100% produced by the students at CTEC. And they have been working all year. And big thanks to Lisa, their instructor down there. And they're learning quite a bit. Because when they can produce things on their own, send them to us, and then we're able to show those, they're moving in the right direction. Hey, we do have phone tutors available until 5:30. We've got Zenaida in studio, and also Jacob, 5th grade student from Penn Elementary, part of the Penn Panthers, and you've been there for 6 years, getting ready for middle school next year. Have you given any thought as to what you might want to do when you're older and through with school?
I think I want, after high school, I want to be a CNA.
A what?
A CNA.
Okay, so explain that to me.
A nurse.
Okay, and that's something that you've been wanting to do for a while, and you think that that's...
I've been wanting to do it for 2 years, but before that I wanted to be a vlogger.
Okay. You're going to have a lot of chance to do that, I'm sure, as you're going through junior high and high school and stuff like that. Any particular topic?
I wanted to vlog trips, or I wanted to show ASMR.
All right, well, good. Well, you know what? I'm sure you're going to be very good at it and very successful with it also, right? You want to try another one of these problems with the order of operations? How do you think that one up there looks?
Yeah, let's check this one out.
A little bit longer now, right?
Yeah,
so here's some other things, and Zenaida's going to help you out in case you're not sure where to start or what to do.
We saw great success with the last problem. You talked to me about how you want to start with multiplication or division. This problem, we've added a parenthesis to you, so let's see what you think would be the right first step.
The first step should be the parenthesis.
Oh, good thinking. Go ahead and solve that. All right, and what do you think would be your next step?
I think it should be the 40 divided by 21.
All right, because that's your division right there, right? So let's go ahead and do that. Now, how about you, when you solve that, the 40 divided by 1, how about you solve it like over there so you don't forget that you have that 3 in between, okay? So when you divided 40 divided by 1, you got 40?
Oh, sorry.
Or,
Yeah.
yes, right?
So maybe, Jacob, an easy way to do it is, you know how you drew those 2 lines underneath the 3 times 7? So whatever you're going to do, draw the 2 lines. So erase your 40 divided by 21.
And draw your 2 lines
There
for
you
the
go.
40 divided by 1.
That'll be easier to track.
Good. Okay, and maybe we can keep doing that because what would be, so you have your division, you did parentheses first, then you did division, and what do you think you would do next?
I would do 3 minus 21.
Now, before you do that, my suggestion is maybe just rewrite everything underneath it first.
So you can look at it clearly. So you can write your 40, maybe underneath there. So write your 40 that you have here.
Oops.
Or you could even kind of keep it going from that 40. So you have that 40, you see that plus 3? Write that there, plus 3. Minus, you got this, this 21 here. And this, I think this division just came from over there. We forgot to erase that. Do you want to erase that? Okay, and then your plus 7 right here, minus your 5. Now look at it again and see what might be your next step.
40 plus 3.
And I have a question for you. You have addition and you have addition and you have subtraction here. How do you know to start there?
Because there's no times or division or a parenthesis, so I should start at the front to the back.
Yay, good job. Good explanation. Go ahead. Writing on this board is not that easy.
Oops.
It's okay. You're adding your 40 and your 3, right? You got your 43, okay. Okay, you can do that if you want, and then we can, you want to rewrite the whole thing? Okay.
Oh.
You can. It does help you stay
Yeah,
organized.
there you go. That's better. Just do one step at a time. Perfect.
Very good. Keep going. Good. Okay. Almost there. You're doing excellent.
Oh, you got very close, right to the very end.
You're literally all this work. Really good job. 29 minus 5. 29
Oh, minus.
Yes. Yeah.
I thought it plus first.
Yeah, you totally.
Yeah, I was going to say the plus, there's the 3 for the 34.
Really good job, Jacob.
Which is a beautiful illustration of why you want to take a look at it once again to make sure, because you did all of the steps in order, you were going right along. And then imagine if you turned it in with 34, you go, oh, I know it was 24, but you wrote 34 for some reason right there, all right? Nicely done. So come on over here, Jacob. You've done some fantastic work so far today. You feel pretty good about order of operations now? Good. So when you get ready to do those in your regular classroom, hopefully the work that you and Zenaida did today helped you out a little bit right there, all right? This is kind of like a little riddle, so we're going to take a look at this together. You can see it up on the screen right there. It says, the sum of my digits is 2. What does that mean, first of all, sum?
Like it equals 2.
And how will it equal 2? How do you get the sum? Do you add, subtract, multiply, or divide?
Both. I mean all.
All of them? So if I want the sum, that's not going to be all of them.
Yeah, but like separately.
let's take a look at the rest of it first, and then maybe we'll see what to do. All right? I'm greater than 12. Who am I? So we need to figure out what number this is. So it's a number greater than 12, but the sum of the numbers that are in that number, the digits that are in the number, make 2. So do you have any idea what this might be?
Greater than 12, right?
Right. It's got to be greater than 12. So let's think, what are you thinking about? What numbers are you thinking about?
Like equal numbers.
Such as what?
14, 16.
So 14, right? So if you take 14, and the sum means to add them, like the 1 and the 4. So what is the sum of 1 and 4?
5.
5. So 14 would get you 5. But we need a number where when we add the digits up, it's going to be 2. So what other numbers do you think you can come up with? So we know 14 won't work because that gets a 5, 1 plus 4. What are you thinking of next?
6.
6?
16.
16? Well, what's 1 plus 6?
1 plus 6 is 7.
That's not 2, is it? All right, keep on going. What else? You just tell me as you keep thinking of numbers. What are you thinking of?
11.
11. If you take 11 and you go 1 and 1, what do you get?
12.
Well, you get 2, right?
Yeah.
Okay, so let's take a look at it. It says the sum of my digits is 2. So 1 and 1 does add up to 2. But it says I'm greater than 12. So can we use 11?
No.
No, we can't, right? You were right, you almost had it, right? So it's got to be a number bigger than 12, where when you add those two numbers up, they add up to 2. So what else are you thinking of?
21.
21. All right, let's take a look at that. 21 is 2 and 1. When you add those up, what will the sum be?
3.
3. Ooh, you are so close, right? Now, if we did 2 times 1, it would be 2, but we can't do times. We have to add because it says sum. So the sum means you're going to add them. So 21 doesn't work, but you're probably pretty close.
Are we able, if we do like 111?
Well, that would be 3, 1, 1, 1. Oh. That's a good point, though.
I didn't even think of that.
So instead of 1, 1, 1, what else could it be? Try 20. What would you get if you had 20?
40.
Well, if you had 20, what would the two numbers add up to be?
Oh, 2.
2. And it's greater than 12, isn't it? Now, what you were doing is 111. Let's try 101. What's 1 plus 0 plus 1?
Wait, 1?
1 plus 0 plus 1.
2.
2. That will work also, right? So nicely done. I didn't even think about that one right there. Hey, you know what? Hey, we've got a lot of different ones. 1.1, things like that. 1.1 million. Yeah, all right. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.